Hello, can you hear me? Yeah, it's muted now. Okay. Can you hear me now? I have to unmute or what? Can you hear me? Again, echo is coming. Now I should close this then. No, can you hear me or not? Cannot hear me. Yeah, you guys can hear me now. Can somebody send a message? You can hear me? Yeah, that's great. Okay. Well, I think I have seen. Welcome to live chat session of this course, Cathodic Protection Engineering. And I do see there are about 12 people are joined the live session. Now, what I see here is there's one question so far that has come to me. Let me read out this question, and then I will also respond to the question. The question is as follows. We have CP stations installed across our pipeline to protect pipeline from external corrosion. Even though after 15 years of operation, we faced internal corrosion issues. Pipe roughness values have increased and requires more operating pressures. Is there any way to reduce pipe internal roughness and reduce pressures? Also, the pipe stretches where 33 kV transmission line across is there. Observed pipe ruptures due to internal corrosion. Now in a position that we cannot divert the pipe. Let me first go to the first part of the question. Correct me if I'm okay in understanding your question. So there is a pipeline which has been cathodically protected, and it was there for 15 years of service. And there is only internal corrosion, there is no external corrosion. So which means I assume that the pipeline is well protected cathodically. So cathodic protection is not an issue at all. Now, if I go by this observation that you made, it appears that the internal corrosion is the main issue. You would know that the cathodic protection installed to protect pipelines or any buried structures, it does not any way influence the corrosion internally in normal circumstances, unless otherwise there are some mechanical joints and different gaps are there and all like that. So the internal corrosion essentially is related to the fluid that is being transported internally. Now we need to know why the corrosion has occurred for years of time. That means what is the kind of fluid being transported, what are the corrosive species present here. And so we need entirely different types of corrosion control measures in order to avoid external corrosion. If the pipeline is already roughened inside, and naturally it reduces the pressure, and so you need a higher pumping capacity. Now, of course, once the pipelines are damaged, it is hard to do anything. But you need to also look at why is that the pipeline roughened. Is it because some scale formation? If you can pick them, then these internal deposits can come down. So when I say that the pipes are roughened, I was assuming that the roughening is happening due to corrosion. But it is also possible that some kind of fouling can happen. That also can cause the internal roughening, in which case there is going to be significant pressure drop. So you need to understand why does it happen. Is it because of any kind of depositions, fouling? In which case you need to do picking. Again, picking is, is another issue. There are certain requirements the pipeline need to meet in order to be pickable. Of course, there are engineers and technology. They look at it and see that it's pickable or not. That's the one part of it. It's possible also, to reduce the internal roughening, maybe by giving some coatings, if possible. Right? Some kind of coatings is still possible, so that we can make it smoother. But then the internal diameter can be significantly reduced because of that. So we need to look at the pros and cons and arrive at the right solution to the particular problem. The other issue you talked about is the 33 kV transmission line, I think, crossing. So one has to really look at what kind of interference corrosion that is going to cause, how much is the induced current that can happen into the system. And generally, the induced current, if it is going to be AC, for example, then you need a large amount of current in order to have significant corrosion. Generally, AC introduces the least amount of corrosion as compared to the DC current. So one has to look at what is the extent that the induced current is transmitted onto the pipelines. If the induced current is not very significant, then it's not a problem. If it is significant, then you need to look at whether that current is inducing corrosion. Of course, there may be other issues when you have high voltage transmission lines. There can be safety issues involved because of the AC induction. That proper grounding and all required for that actually. So this requires a more detailed investigation to find a right solution to the problem. Okay, and the solution is always specific to an individual case, and so that has to be analyzed much in details. I hope I have responded to you people on these questions. Yeah, I do see there is a question by Mr. Raghavan Gopalasamy. Normally for CP protection, nickel cadmium batteries are used as power backup. Is it possible to use lithium batteries? You know the lithium batteries are expensive. Right? In principle, yes. I mean, all you would require is a DC source, right? In principle, possible, right? But the lithium batteries are expensive. See, the advantage of lithium batteries is the power density. It's more transportable. You can put it in the vehicles, put it in the mobile, all are possible. So, in principle, yes, but economy may not work in favor of using. I would say use lead as a battery. I mean, of course, lead is not environmentally friendly. Okay, so you can use lead as a batteries, and it should be cheaper than going for nickel cadmium batteries. Yeah, yes, Mr. Raghavan, I'm not understanding what is mean with BMS. Can you elaborate on what is BMS means? Yeah, there's a question by Avajit. Please solve or give hints of the assignments in numericals. Okay. I have given one tutorial, I think, right? So I would urge all of you, please go through the tutorial and that gives you an idea about how to solve the problem. The, the role of giving assignments is just not finding a number or a solution. The idea of giving assignment is to see whether you understood the concepts. Right? So, moment I give a hint, it doesn't take me a minute to do that. Then I don't think you could catch the concept. So, giving hints, yeah, probably it might work. It must be much easier for you to solve the problem. But you, I hope you'll appreciate that giving an assignment is essentially to enable you to understand the concepts, not to just to solve a problem. So that can be done by any of us, right? So I would suggest that we would try hard and harder and solve the problems, and then we can give you a solution as to how that particular problem has been solved. Then you can be able to understand the concepts. So it be counterproductive to give hints because you simply don't do anything. You simply going to solve mechanically the problem. So when you are looking at uh, the videos, I would urge you to understand, get clarity, get the concepts. Um, then just looking at these numbers. Just now I've described one problem. Right? And, I think one of the participants posted the problem. But you know that, I have never seen the pipeline. I never know what the problem is. Right? But how does one solve the problem? You solve the problem by understanding the concepts. Because you're not going to see the same problem again one more time. Right? So basically, that should be the spirit of learning. Okay? So, yes, so calculation of the number of anodes is my main problem. So can you tell me what is the problem? Can you please explain to me where was the problem? We need details, calculation in problematic things, right? Okay, let me ask this question to you. You may be knowing the relation, right? Why would somebody increase the number of anodes? For example, if somebody is using a sacrificial anode, right? Suppose you're using a sacrificial anode, let us say. If I use a sacrificial anode, what are the reasons one would increase the number of anodes? Can somebody answer me? What are the reasons for that? What makes you to increase the number of anodes if one is using sacrificial anodes? Can you tell me what are the factors? Factor one, factor two, factor three. Can you now tell me, you know, and what are these things that would really say, okay, that for these reasons I would increase the number of anodes? Can somebody respond if one is using a sacrificial anode? Okay. Why should one would increase the number of anodes if it is a sacrificial anode? Can somebody attempt? Yeah, one, of course, I need to have required amount of current to protect the structures. Okay. So if a given sacrificial anode has certain current density, I need to have more area. Okay, one, right? That's one thing. Any other factors that the number of anodes are deciding? One is the current. What else? Anyone? All of you can join, right? We all 11 guys are there, 12 guys are there, right? All this you can join, you can help Sanjay Kumar. One is that okay, we need the required current and for protecting structures, the current density, the area, so you can do that, okay? Yeah. So annual consumption, right? So okay, what is soil resistivity? Why should we worry about soil resistivity? Because the given anode should give the required potential to drive. Okay. So the soil resistivity becomes one factor. If the soil resistivity is more, then the voltage will drop, and so it won't give enough driving force. Right? So if you are going to use zinc anode and magnesium anode required less number of anodes, because for the same soil resistivity, the magnesium anode will require less number because the voltage offered by the magnesium anode is quite large, right? So, but you have the equation, right? For example, okay, now you have to go back, right? You need, of course, there are little bit of permutation and combination. So one of the most requirement is that suppose I use a sacrificial anode. The sacrificial anode has to overcome the resistance offered by the circuit, right? Resistance is offered by the cable, resistance is offered by the anode, resistance is offered by the pipeline, for example. There are three ingredients, right? So you have resistance offered by the anode, bed, resistance offered by the pipeline, resistance offered by the cable. They're all in series. You can't change the resistance offered by the cable. You can't change the resistance offered by the pipeline. The only thing that you can change is the resistance offered by the number of anodes. Right? Now, how does the resistance offered by the number of anodes change? That depends upon soil resistance. But if I increase the number of anodes, the overall resistance offered by the anode ground bed becomes less. So if you increase the number of anodes, the overall resistance offered by the anode as overall is decreasing. So you need to find out how many number of anodes would be sufficient to overcome the resistance, right? So you know the current, right? You know the current required for a particular pipeline. You know what is the voltage offered by the anode. So you know what is the resistance it can overcome, right? So the pipeline would require to be protected not less than minus 0.85, not more than, I would say, okay? Not more than minus 0.85 volt with respect to copper capacitor electrode. Any voltage lower than that, that means more negative, is acceptable. Okay? So to find out, you know the criteria, you know what is the criteria for cathodic protection. So you know the criteria for cathodic protection, minimum criteria for the cathodic protection. You know the voltage offered by the anodes. So you know what is the driving voltage available, right? You know what is the current that is available. Now you use Ohm's law. Then you find out what is the maximum resistance the anode can overcome. Do that. So what I want you people is to get that feel of it, get that concept in this. So you have a pipeline on one side, you have an anode on the other side of it. Actually, the current is flowing between these two. The anode drives all the current. How does anode drive? Actually, it requires a voltage drop. What is the voltage given by the anode? That is known. What is the minimum required voltage for cathode protection? Also known. So what is the delta I value? You know that. You know the current. You can find out the R value. Now you know the R value of the pipeline. You know the R value of the cable. So what should be the R value of a anode? R value of the anode you can calculate given all the dimensions, resistance, all are given in the equations. Right? So you must be able to calculate actually. Okay, that's what I'm trying to say. You need to think. If somebody is going to give a hint for you, you are going to solve it. Then you are not going to look at solving problem. Right? Solving problem has to you have to think and give a solution. So that is what is important. But again, somebody says that I need cathode protection for 5 years, then I need to know how much current is required in 5 years, whether weight of the anode is sufficient or not. So go into this concept, then you'll get to know what to do that. So it is the concept. Finally, it is the concept of what do you mean by cathode protection? What is the role of an anode? What is the role of an anode if it is sacrificial? What is the role of an anode if it is compressed current cathode protection system? That point, I think, you should be looking at it. So I would always like that, not how much you read is not important, right? How we read and how we got the concepts clear is what is. So there should be always some hidden thing for you to think more. If everything is listed there, then you cannot think. You can't ground your concepts. You need to ground your concepts. That is the whole idea of giving this problem. So that will enable you to think more and find some. Of course, I do see one problem. It's a frustrating for online course. If it's a regular class and maybe interactive, I give some solution. Then you go one step further, you can solve it. That is something which is not possible, unfortunately, in an online course. Okay, I do feel very bad about it because it's not that physically I can help you out to go. It's like hand holding. I will help you out to move one step, another step like that. That is simply not possible because of online course. Unfortunately, yeah, that's limitation that we have. So the point I'm trying to say is that try to grab this concept. Then you write questions. Then you discuss, right? Then you have interactive. You can send email, right? Have one step. Somebody gives you off the answer. You start moving further into that. Okay? So go for interactive mode. And we have TAs with you, and TAs are not able to answer. I'm there to help you. But initiate your discussion. That's the point. Now, I hope you understand my intention of how one will start learning a course. Now, let me go to a question by Prabhu Devasi. Suppose iron and copper are connected to each other and placed in soil or other corrosive environment, then no doubt iron will corrode more and copper less. So here to protect iron, can we use cathode protection? How it will affect? It's a fantastic question, right? The question is very fantastic. I suppose if you have done a course on galvanic corrosion, I suppose some of you guys know, right? Galvanic corrosion is what you have two dissimilar metals, right? When you are electrically shorted, the one which is having a potential relatively more negative. When I say potential, I mean the corrosion potential, galvanic potential. So between the metal, the one having a lower galvanic potential, I mean more negative potential, will act as an anode. Other one will act as a cathode when they are electrically shorted. If you don't short them, they don't. There is no galvanic corrosion. That's what is done now. Now, in order to protect iron, what you should do? You should have one more metal, which is anodic to iron, right? Suppose what should be anodic to iron? It is zinc. So you can connect the zinc, it can happen. That's what people do in a heat exchanger. In galvanic corrosion control, which is similar to this actually. The people use zinc anodes so that you protect iron, you protect copper. Of course, what will happen to copper? Copper, nothing will happen. In fact, copper anyway is cathodic to iron. It's going to be cathodic even to zinc. So nothing will happen to copper. Copper will be well protected anyway, even without addition of zinc. Now the addition of zinc will enable that iron does not corrode at all. So this concept can also be used even in the case of pipelines and structures where you are going to use what is called as grounding, right? Sometimes people use grounding for when you want to ground the structures or steel structures, you use copper. So sometimes there can be galvanic corrosion between copper and iron. Locally it can happen. In which case you use zinc. Otherwise, you can simply use zinc or galvanized steel as a grounding system, you can do that. That also can be done. Yeah. Yeah, Anil Mishra actually. The numericals of assignments are difficult to solve, to give solved examples of similar type. Yeah, that's what precisely I'm saying. Okay. Well, the precise problem is that I would not, encourage people that to solve a problem, you see that example. You have another problem exactly similar, only the numbers are changed, you plug in the numbers, right? Suppose tomorrow you become a teacher, right? You want to create a new problem. How will you create a problem? You just take the problem and then you change the numbers, do that? No. Again, when I think I given 3 problems to solving, right? If I give you, let's say, fourth problem for your thing, suppose I give you the fourth problem. My fifth problem will not be same as 1, 2, 3, 4. No. That will give you an idea as to how I solved the problem. So even I give fifth problem, my sixth problem will be there, but it won't be similar to all 5 problems. If I give that, then you are not on your own trying to understand the concepts. So solving a problem by itself is not a problem. Okay? What is the problem is trying to understand the concept in that. Okay? When you have the concepts are known, then you start looking at, you start drawing yourself. That is what the whole idea is. So I am trying to move in the directions. Okay? So even you give that, okay. So it is essential new person. I understood actually. It is essential new person. I don't think I would disagree with you at all. It's new person is very. This is in fact I have one difficulty. Online courses. This is one of the things that we don't interact actually, right? It's something like interaction. It is like you have been taught to make a painting of a tree. Tomorrow the teacher asks you, please draw a painting of a river, right? So you will not ask same to paint of the tree again, right? It doesn't really help you out on that. So that is the problem. Okay. If you are learn how to paint for a tree in a class, in the final exam, if the teacher says, please draw again, paint the tree, I think that you have not learned, right? The trick of painting you have to learn, not painting of a tree you should learn. Okay? If you learn how to paint a tree, I think you are lost. Okay? If you learn the trick of painting a tree, then I think you go into that. Okay? So that's what I think. Even in my view, even if you catch 60% of my course, if you learn how to do that, I think that will help you a long way in your career. Okay? That is what, in my view, is learning. You have to keep trying. You fail, no problem. Let us not worry about it. Don't worry about failing some problem at all. Okay, you have some issues. Okay, please send me an email. I am there to help you out on that. Okay, okay. It is okay. So of course there is one problem I find with this course. This course is a little more advanced actually. You will have to learn. Have you guys attended any course on aqueous corrosion, petrochemistry? How many of you have learned the aqueous corrosion control course? Any of you guys? You please learn. What you need to learn again, see, is one difficulty that I find is this course is not, a first level course. It is second level course. The first level course is aqueous corrosion and control, which I have given in details about what is corrosion potentials, what is equilibrium potentials, what is Staffel line, all are given in that actually. And those people who have done that course, it'll be easy for them to look at the relation between voltage and current. For example, Staffel relationship. Right? And unfortunately, not there. What I would say, maybe I will request our TAs. Can you TAs give the link for my aqueous corrosion YouTube things? Please read 2-3 lectures which are related to equilibrium potentials, related to over voltage, how the over voltage is related to current density. Can you please link? I will request that TS do that. They will send you the link to that actually. Please do try that. Okay. And I do see that if you are not are fully knowledgeable about the electrochemistry in terms of the over voltage, current density, exchange current density, topple slopes, I think yeah, some of these problems are really problematic actually, right? So I will request them to send you a link. They will give it to you. Please do listen to that. And if still you have a problem, I think let us exchange some notes. I think our TS are fully equipped with that. What again I request you people is that let your question be very sharp. See, I do see that sometimes you people are having like, I'm seeing the video, I'm getting something like that, video from seconds, 10 seconds to 13 seconds, I can't understand. No, please don't do that. Please attempt and then put your question. See, framing the question itself is a learning. Okay? It's not easy to ask a question. Okay, when you are seeing these videos, I do see the problems. Then you suppose you see that videos from let's say 10 seconds to 20 seconds, you are a problem. Please tell what did you not understand. I can't understand from this time to this time. I think that is then what happens is then you are not framing your question. Framing a question itself is the learning. Okay? You would never, you would never benefit from a course that doesn't provoke you. If the course is so passive, it doesn't provoke you for thinking. It doesn't help you to think more. I think that course is not going to help you. It's going to make a damage to you. Okay? In all your lifetime, you are not going to do same thing. Please let me see. Let me know. You keep doing different things. What these courses will make you stronger is how do I analyze the problem? Fail, no problem. Doesn't matter. But you learned it. In some case, you pass it, but you not learned it. So what do you like? Okay? Failing and learning, you like it? Or you passed it, but not learned, you like it? I would go for failing, but learned is what one should do that. So these are something is very tough. It's very tough. But then all your time is useful, not wasted at all. Okay? So try to do that. Any questions are there, please do let me know. Send to me very precise thing and all. Actually, this is not a problem. The good thing about this course is, I do find very good thing about is that your exams are going to be in sometime in I think March, I suppose, right? March, right? Isn't it? So all your assignments are over like that. I don't mind coming back in live and explain to you each and every problem. Okay? Then you catch that. Okay? Till that time, you keep hitting it. Okay? But again, we can help you out, but ask us some small questions. Don't ask a question that we solve all the problem and give it to you. It's going to be of no use. It has no use for any of you. Okay? So again, my earnest appeal to you people is that try to climb. Okay? If you're falling down, school, no problem. There's no fun in walking through a road which is so well laid down and all kind of places, because you never able to do that. Okay? And it is, in fact, I know so much that you people have problems because it's online courses are sometimes it's hilarious, because you, as you said, then where this guy is, somebody gives a lecture and forgets it, not something. There's no hand holding, no, that's not there in the course. We'll try, but be bold enough. Write to me, write to him actually. And I think some of these people are already taken the course. Some of them, in fact, edited my videos and all. They are aware of it actually. Okay. I am also be very happy to interact with you all along. Anytime, we are always very happy to do that. Okay. Anything on electrochemistry or problems, let us discuss. Let's discuss. And also, in my view, I would like to see that some of you answer the question, not me. Okay. I will answer question only when you people cannot answer the question, because it also provokes your question provokes other person to think, right? He gives answer for you, okay? Because you are helping other fellow to think. If I give an answer immediately, I think it's almost like in inflated balloon. Balloon does not even take away from there. Okay, so I don't want to quench your learning process, and that's how it is there. And of course, it's not a, a nice thing that things are not really available, but I think it's there. So what I can do is once we have this all assignments are done, I can come on live and I can solve this problem and I can tell you how it has been done, what are the steps involved, what is the analysis, all we can do that. Okay. I will be very happy to do that. But first attempt, you please do that. And don't worry about the marks. I think that is not something you will carry with you anymore actually anywhere. Okay. You go to industry, you solve the problem. I mean, that time this mark does not come to you at all. Okay, I will try to see, go through the numericals again and see whether we can help you out. And, we'll see that how this numerical can be. Gate exam, I'm not sure this is going to be a gate exam here, right? I think, Shivam, this is not for the gate exam, right? I think gate exam, this is not going to come, I suppose. This is not going to be a part of the gate exam at all. Yeah, Abhijit, that's what I think you do that. You please send the link through the announcements and let the people learn. I think, yeah, it is a problem because this is there are some there are inherent problems in this kind of things. We are preparing modules for half an hour, and half an hour covering something difficult. Yeah, anyway, this is something we don't want to get into the other kind of limitations. But nevertheless, please ask questions, and that's the only way that you learn. How many of you people are familiar with electrochemical concepts? Any of you in this all this? Now I think there's some. Now around 8 guys are there. I think the many guys have left. No problem. Among I think again 8. I think maybe some 3 of them maybe TAs. Or maybe 2 guys are TAs. 3. So only 5 guys are there. Among 5 of you guys, how many of you guys have attended any formal course on electrochemistry? Yeah, okay. Yeah, Lakshman, what we do once you people solve the problem, we'll give you the solution actually, and we also tell you how we solve the problem. What is the methodology? How it is oriented. Okay? Okay, so that will give we will all the problems that we were given, and maybe what we can do is I think the TAs, Sandeep and Abhijit, once the problem, once this assignment number 1 is over, what we can do is you can solve the problem and we post it. Okay? Because again, this the problem here is they're all numbered. They're not giving details about. That's one of the problems. So we'll solve the problem, give them in details, and explain why each step is important and post it so that all our friends will understand it better. There's one question that is about Prabhu Devasi. I think, yeah, how pH will affect erosion, right? More solution. Okay. You know what the pH means, right? What is the pH means, right? Anybody can tell me what is pH mean? Can quickly tell me what is pH means? Yeah. What is pH? What does pH? What do you understand by pH, first of all? What do people understand by the pH? Anybody can tell me? So pH essentially means it is related to the hydrogen ion concentration in the solution. Okay. So hydrogen ion concentration is given. Yeah, you are right. Anil Mishra is correct. Negative logarithm of hydrogen ion concentration. So it is a measure of the hydrogen ion concentration in a particular electrolyte, maybe water, whatever. So it's precisely what Anil Mishra says, like it's a negative logarithm of H plus N concentration. That means higher the H plus N concentration, the pH becomes lower and lower. Right? pH 1 has got more hydrogen concentration to the H plus, isn't it? H plus N concentration as compared to the pH 9. The pH 9 will be 10 power minus 9 moles per liter. The pH 1 will be 10 power minus 1 moles per liter. So lower the pH, more is the hydrogen ion concentration. What is corrosion? Corrosion is an oxidational matter. Let's take steel. Let's take iron. When you put in iron, what is happening now? Iron is getting oxidized as Fe2 plus 2 electrons. Iron is getting oxidized as Fe2 plus 2 electrons. And these 2 electrons have to be removed. Without the removing 2 electrons, then corrosion will not take place. How will the 2 electrons will go away? The 2 electrons will go away by that can be taken by the H plus ions. H plus ions will combine with the electrons and form hydrogen ions. So the corrosion involves an oxidation process, release of electrons. There is going to be an acceptance of electron with the reduction process, and H plus ions are taking the electrons. Now, in a simple chemical reaction, if the H plus ion concentration increases, then the reduction reaction increases. That is what happens. It is a Lee-Chatterjee principle, right? If you look at the K is proportional to the activity of the reactants. What is the reactant here? Reactant is H plus ions. So more H plus ions, the reaction rate increases. So that means H plus ions increase the cathodic reaction, and so it also can increase the anodic reaction. That's one part of the story. The other part of the story about H plus ions is that, if we, again, if you've done a full course on corrosion, you know that the metal also can become passive. What is passivation? In forming the oxide film. The oxide films are formed on the metal surface. The oxide film formation depends upon the pH of the environment. Higher the pH, then form oxide films. That means the corrosion rate is decreasing. So the oxide film formation also is related to H plus ions. So alkaline solution, relatively higher pH solutions will enable passivations. So lowering the pH causes corrosion for two reasons. One reason is that the reduction reaction rate increases. The second reason is that it lowers the passivation. If passivation is lowered, then the corrosion rate is increasing. Now we know one example is that steel in the concrete, right? The steel in the concrete does not corrode much. Why? The concrete pH is going to be alkaline. Okay, what it is going to be. So the role of pH will be seen in the light of that. One is that H plus ions promote the reduction reaction, which is part of the corrosion process, and H plus ions also reduce the passivation of the metal. So that way, pH is one of the important parameter corrosion. In one of my lecture, I think I have given you what are the possible cathodic reactions. The possible cathodic reactions are, if you go back and see my notes or maybe lecture, one is H plus ions taking electrons. The other reaction is oxygen in water is taking electron and become hydroxides. There may be sometimes metal ions getting electrons like that. So there are several cathodic reactions, and depending upon the pH of the medium, some reaction can be very dominant. Yeah, hydronium ion is different from hydroxyl ions. Actually, hydronium ion, I think, is nothing but it's a proton. Actually, that is, you take a water. In the water, the H plus ion gets attached to the water. Okay, that is Hc3O plus is hydronium ion. Hydroxyl ion is OH minus is hydroxyl ion. So hydronium ion is a protonated water. Hydroxyl ion is OH minus. So there is a difference between these two. Okay, the measure of acidic and basic. Yeah, I mean pH is the measure of acidity and basic. You can say that. Of course, the acidity, basically, if you go to much deeper, you can also define acidity and basicity without even involving H plus ions. But that is a different, they call Lewis acid stuff, right? We'll not go into that complexities as the chemistry guys are involved much on this. But right now, we're happy with defining um, acidity or acidic pH in terms of H plus ions. So, any other questions? Anybody's hand? Okay. Yeah. Good evening, Kanu Charan. Okay. Good evening. I hope this interaction has been useful. I think more often this gives you more energy for learning than the actual thing, because you can't cover too much in 1 hour. But nevertheless, great guys. So if you guys feel that there's no more questions, please let me know, and um, we can close the session. I have no problem even continue beyond that, 1 hour also. But in case you guys have specific questions. Okay, and so if there are no further questions, thank you all for attending this live session. So before I conclude, I would like to say that the course is meant to be thought-provoking, to provoke you to think more into that. And that is one of the main objectives of not only this course, should be of any course. The second is it should enable you to learn more than simply accepting whatever I am saying. If you are going to simply accept whatever I am saying, then you are going to be a passive learner. You are not going to question the teacher at all. You should question the teacher. Anybody who teaches us. So that is another part of this one. The third part, of course, the course should not be too impulsive that you cannot really enjoy it actually. So it should make you enjoyable reading. So that means whenever you ask some questions, you please shoot these questions. We'll try to answer you as much as early as possible. Okay, so that I think because it cannot be a course with you simply no use. What the point is simply attending a course without understanding it. Will enable you to understand wherever you ask questions. The last point I would like to say is that, and please go through the workout examples which are given you. Please understand how I solved. What is the way it has been done? That is what you please learn about. Don't worry about the numbers. That is not the thing. Don't worry about the equation. You must understand why did I use the equation, right? There are 5 equations. Why I am using the only one that equation? Why not some other equation? Right? What is the relevance for that? That's the point you learn. So lastly, after you solve the problems, okay, and assignments, we will release you the answers. We'll also tell you how we can, um, how you can think and solve the problem. Okay, I think that part I think we will do. Okay, um, so that you enable to catch up with what you are not able to do this. Okay, so with this, I think we can close the session if the people do not have any more questions. Okay, so thank you guys. Okay, and we can end the session now. Actually, yeah, thanks a lot.